So design of simply supported beam. So by using stadd analysis. So you go to new project. Next, click on space. And then length units meter and kilonewton. And the next, add structure name. So next, so enter all the details. You select add beam. Then finish. So next, the snap using snap node. So remove the grid and the distance of first node point is enter is 0 and enter the first node is created. So you are using the x distance. So for example 10 meter I will given. So enter. So this is a vertical direction is created. So we change the direction. So put in the x node. The value is 10. So x value is 10. So the node is created in the two sides. So you are select add beam cursor. Next, add these 2 points. Next, you click the view from Z. So this is a beam. There are two nodes and one elements. So next, go to general category. Uh, Select define. Then you choose the beam properties. I'm selecting rectangular section. So the value is 0.23. So all the values is considered in meter. So put it the value 0.23 and 0.45. The material is concrete. So next, add and close. So next you go to select the concrete and assign to view, then assign. So the beam number is selected in the rectangular section. Just to create a 3D rendering mode. So the beam section is rectangular sections are created. So next one, go to general and then select support and create a support. So create a support. So next time I select the fixed support for the two nodes, add and select the support to use cursor to assign. So assign, then go to with the two nodes. So both ends are fixed conditions, beams are created. So next you close the tape. Next go to load and definition. First you select the load case details and then add. You will select first one dead load beam, add. The next one load case 2 a live load of the beam, then add, then close. First you select load case 1, then add, you select the member load, first you select the self weight of the beam, the factor is -1, so then add and then close, and go to second one load case 2, then add the point load or uniformly distributed load. So it's a member load, uniform force or uniform moment or concentrated moment. So there are many number of forces are available. So first I'll select the uniform force in -20 kilonewton per meter, uniform force or uniform moment, add then close. Next you select the self weight of beam and assign to view and assign. So load 1 is selected. So next you select the load case 2 in uniform force and assign to view, assign. So both loads are selected. Next you go to commands, uh, analysis, or first select member information pre analysis print, then click to view. Okay. Next you go to analysis, perform analysis, then select all. Okay. Next go to commands, analysis, post analysis and print, analysis and the result, then yes. So and go to analyze, so run and analysis, then save the structures. So once you select the analyze, once you analyze the structures, you cannot modify any number details. So next is the output will generated. So next the structure returning output is zero error, so zero warning. Then click done. So go to mode, post processing. You select and apply the road case 1 and OK, apply and OK. So you select the beam, so the bending moment, shear forces, and the stresses on the beam. The graph, you select the graph. We are using uniform force, the maximum moment, the displacement, and then shear force. All are shown. So next, select the stresses in the point. So select or move the distance. I am draw the distance of 10 meter. So the stress points noted in the different load condition, one self weight and one live load of beam. And the next we go to modeling, just double click on beam, shear bending, just move the cursor the distance of 2.49 meter. Force and moment, shear force and moment is 6.135 and minus 21.935 for the load case 1. Load case 1 is a self weight and the load case 2 is a uniform force. So the moment is calculated in along the span. So next the deflection using load case to just move the cursor, the distance, the displacement, the deflection in y direction, the deflection in y direction, not in z direction. Select the distance, then local deflection and global deflection. So there are two categories. First you choose the global deflection. So deflection is created by vertical direction only. So this is a distance of span minus 1.635 is a 6.6 meter distance displacement, and 9 meter is zero displacement, then 8.3 meter minus 0.63, so it's a displacement. So next the loading and shear bending. So this is a shear bending, load case 2 and load case 1. So next click on print and final output. Thank you.